Anyway, so I think next we're going to do a short Q&A with sort of an OpenZFS Q&A just before we kind of get the beers. So just, open the floor up, 20 questions and 20 questions on the live stream, about ZFS. So if Matt and George grab the mics. So any questions kind of about ZFS, about, deep dive, I suppose, maybe performance issues or experiences or suggestions or features or questions about where George got such a great shirt from. I don't know. But yeah, so anything kind of, open it all up to anything and everything. Anyone?
Yes. It's about SSD on ZFS on the mainline storage with is a recommendation to use it without errors too quickly.
Just following that presentation about whether to use NAND as a pool disk.
SSDs are great. I mean, they're super fast. For any kind of random read intensive workloads. I mean, we recommend them to our customers because our customers are mostly using databases, and databases are very random access intensive. So I know lots of other vendors do all SSD pools with ZFS.
It just works.
Yeah.
Yes, it's about the with the cost of SSD, we choose perhaps YZ, but the I/O spread on it, there are a lot of little block. It will be better to have a large block size to spread it or any.
Yeah, because I think that kind of like follows up into Raina's presentation where SSD's failure rates are very predictable, and whether putting them into mirrors, for example, would present in situations where SSDs would fail en masse with data loss.
What type of record size do you use? Do you typically do large writes?
Test it.
So what kind of workload are you using? Databases?
Virtualization.
Virtualization. Yeah.
We don't know the workload.
I mean,
it's a random, but
yeah. So like using virtualization with 4K block size or 4K or 8K block size or record size in ZFS. If you're using RAID Z, then you definitely want to be using disks or SSDs with 512 byte sector size.
Yeah.
Otherwise, you're just wasting space, and you'd be better off using mirroring. That's basically what I said in that blog post that we brought up briefly. You don't want to be combining small record size with almost the same size sector size, so like 4K record size, 4K sector size with RAID Z, because you're just going to have 2 copies or 3 copies of the same data, so you might as well just use mirroring. But aside from that particular case, like it's going to be fine. Like if you're using 512 byte with 512 byte sectors with RAID Z with 4K or 8K record sizes, like it's not going to get as perfect of there's going to be a little bit of space overhead to using the RAID Z. Like if you have a RAID Z1 with 5 disks and you have 4 data and 1 parity disk, it's not going to be exactly 20% parity overhead. It'll be a little bit more, maybe 25%. You can kind of look it up using that crazy table that I have in my blog post, but it's still going to be like a lot better than using mirroring in terms of the space usage.
And is that a configuration you guys are actually considering, doing a flash-based RAID Z? Interesting.
I know you guys do that a lot, right?
Yeah.
Exenta.
Just be careful about your physical sectors.
Yeah.
Do I see another hand?
Any other questions?
Just going to emphasize what you hinted at, which is that bear in mind that the flash drives in each VDev die exactly the same time.
Yep.
Seen that with a customer.
Yeah.
Thought, we'll replace that, and sometime this week it didn't last. The second one didn't last that long.
Yeah, the one saving grace of that situation is that at least SSDs can resilver a lot faster, because resilver tends to be very random write intensive, which the SSDs can do a lot better at than disks.
I think I saw one suggestion, which was maybe look at putting two in a mirror and then buying a third and then installing the third a couple of months afterwards. So at least you kind of have an offset.
you stagger your deployment.
Yeah. So you kind of like offset your, because ZFS does things like perfectly right across the VDEV, very evenly. So
different
expiration time.
Yeah, that's a good idea.
Different level of gas in each SSD.
Yeah, I mean I think that makes a lot of sense, and I think that like this talk about SSDs, it really does go to the hybrid pool, where like the idea of a hybrid pool and having different types of disks in it is going to continue. It might just be different types of SSDs for different use cases within the pool, rather than SSDs versus spinning disks. Right? You might have your TLC, low endurance stuff for the bulk data, and then other things for L2 work.
And I also think that using a ZIL would greatly help in that situation, not only with the IOPS, but also with the wear leveling and careful management of the ZIL devices, like replacing it from time to time.
Yeah.
That would definitely bring up the lifetime of the pool.
Yeah, absolutely. I imagine that we could do additional things kind of along the Nexenta idea of having disks or devices that are dedicated for metadata, because metadata tends to be overwritten much more often, more frequently, and freed more frequently than user data. Being able, if we had something like that, maybe you use like some high endurance devices for your metadata and low endurance devices for user data, that tends to be replaced less often.
Mm-hmm.
Is my understanding correct that without a dedicated ZIL device, the data is written first to the disk in a sort of a ZIL section and then in its permanent storage place? So for a 300 IO write, we actually have to issue 600?
For synchronous operations, that's roughly correct.
Yeah.
So synchronous operations would be like, a database that's issuing fsyncs or opening things with OSync, or NFS operations is kind of the big use case. So, for pretty much for those kind of use cases, like NFS servers, in most cases,
VMware only. Yep.
VMware only.
Yeah. NFS does not for a mail store.
Over NFS.
NFS can do.
Yeah, it can. Yeah, that's true. It can do, but in a lot of cases, it is doing synchronous
writes. Yeah.
synchronous
Well,
writes.
in particular, like databases, oftentimes the way they open, depending on the file system options, they're going to drive the NFS option that is going to force it to be synchronous.
The biggest consumer of sync IOs on NFS is VMware.
Yeah, for sure. But I'm just saying, other use cases of NFS also have a lot of synchronous writes, even aside from VMware.
Yeah, and I think this is where, understanding the use case is critical, because going with, a low-end SSD device for your ZIL could quickly get wiped out if you have a high synchronous write type application.
Yeah.
The keyword, again, is planning.
Yes.
Yeah, and definitely, like for those kinds of workloads, I think all of us that have experience using ZFS know the wonders of using a SSD for the log device. I mean, it's going to give you hugely improved performance.
And I already alluded to how well everybody plans their deployments.
Mm-hmm. But at least with the log device, you can add it later, and it's just fine.
It later and remove it.
Yeah.
Why not remove it?
Yeah.
You can remove it.
Yeah.
No, from day one. From day one, you could remove log devices, right?
No.
Right, George?
Yeah. No, you can remove log devices. Well, not from day one.
Oh, from what? From 2009? Something like that?
Day 374.
Yeah.
For a while, then there was a bug that couldn't basically break your pool, and then after that was
I don't remember that.
Around build 120,
fact,
But it was a big issue because the traditional zills in the fish works, when you really lost one, you had a big problem. So it was I don't know.
well, yeah, there used to be the big problem where if you lost the ZIL, then now you could no longer import your pool. Yeah, and then you had to like actually say, I want to import this for real, and I recognize that my ZIL device is missing. That was
Has this
the -m option, which was added later.
George, can we say this has always worked on OpenZFS?
Yes.
Okay.
Yeah.
Use OpenZFS.
You know, we had this ghost bug. But it didn't always work.
I don't remember that bug.
When
Yeah.
you took the zil out, the pool would still think it's there. And if you rebooted at that time, your pool was gone.
Oh, I'm not familiar with that bug.
Sounds more like an Oracle bug. Twice to fix it. So we should
Was there another question?
Yeah. I think we all know about the not requirement, but like best practice of using ECC memory, and we do. But I just like an answer to that, which is, okay, let's imagine we're not using ECC memory. What do we risk? Do we risk that after the data has been written to ZFS, let's assume without corruption, because we don't have ECC memory, if there's a bit flip in the memory, could that corrupt the pool or do some damage to already written data? Or is the risk limited to the data that's in transit somewhere in the stack before it's checksummed and written? Because what I mean is, if that's the risk, okay, it's certainly less good to have this risk than not having it by using ECC memory. But in most of our workstations and laptops, we work without ECC memory and we accept that risk, which is a very different risk scenario than after my data has been written in the pool.
I understand.
It could be
Can
corrupted.
I answer? So I want to be very clear that ZFS is more reliable than other file systems when using ECC memory. So I think as we know, the best practice is to use ECC memory for any kind of storage, whether it's ZFS, EXT, Linux, your Mac, whatever. So in all of these file systems, there's always the chance, if you're not using ECC, that some bit of a critical piece of metadata could get flipped in memory and then written out in an incorrect way, right? So like all file systems have super blocks, or like some block that's like controls a lot of different data in the file system. You know, if you're about to write that out and some critical bit flips in there that says, oh, actually, there's no data in this file system, and then that gets written out, like it's corrupt, it's wrong, and that could happen to ZFS. ext2, Windows file systems. Like, there's really nothing special about ZFS there. There's certain things where ZFS can be more reliable. We have some ideas of like in the future, like doing more kind of protecting it while it's in memory. So like the window of vulnerability gets smaller with ZFS. But in general, we can't make any
before
guarantees.
it's written. Before a
Before it's
checksum is
written.
calculated.
Yes.
Now, if the checksum is calculated, if we have all kinds of bit flips, we're just going to detect that there's a corruption, reject the
but the
block,
problem
and
is-
reread it from parity.
The problem is that if you are ever modifying anything in that file system ever again, then you're going to have to modify some blocks, some of metadata that point to other blocks of data in the pool. So like I've written this file, but then in a year from now, I want to write another file. And then when I write that other file, it has to update some piece of metadata that gets bit flipped. Then like everything in the pool could be corrupt because that piece of critical metadata.
It really depends
got
on what
manipulated.
piece was corrupted at the time that you wrote it. That's going to determine it. Best case scenario, it's just a piece of user data that is now lost, right? It checksums correctly because the bit flip happened. We checksummed it, wrote the checksums correctly, and it looks like valid data, but in fact it's logically incorrect. Or you panic the box if it's some piece of metadata that now you read, it checksummed because the bit flip happened before you wrote the data out.
Yeah, and all this could happen to any other file system. They don't even have the protection.
So
of
there is
checksums,
that risk that a bit flip on non-ECC memory would take down an existing pool.
Yes.
Because okay.
Yeah, and that's kind of true. Like taking down the existing pool is kind of the best case scenario, because the alternative is flipping a bit in your user data and we give you the wrong
Yeah.
data, right? Like,
Yeah, and then you use it.
Yeah, and then you use it, and you're acting on the fact that this guy is not an employee anymore, or this guy has instead of $1 million in his bank account, he has $0 in his bank account, right? All those are horrible scenarios that could apply to any file system.
And far more likely
Wi-
by volume.
Yeah, with others.
Yeah, but I think what's difficult for a lot of people to understand is that do you lose the entire pool? That's what a lot of people are struggling with. Do I lose the entire pool, or do I lose a piece of user data? And with traditional file systems, they
With traditional file systems, you could lose either one.
Yes.
both, but
Same with ZFS. You
there
could lose
are-
either one.
okay, but people reverted to check tools, data recovery tools, and
Yeah, you could do, same with ZFS, right? You can
No.
you can recover some stuff some of the time. You can call George to recover stuff other times. You can call drive savers
it is not
to recover stuff other times.
it is not that simple, because if you lose the pool, there is no third-party tool which can walk the raw structure and sort of try to enumerate.
I'm no third-party tool.
No. But that's you
Yeah,
can
so
can.
I think the question was about his question was about theoretical possibilities. Yours is about practical concerns of like once
Well, in
once
the end,
corruption
it,
has occurred, how can I recover from it, right?
Oh yeah, and sir, regarding the ECC question, there's a paper where memory fault injection has been applied to ZFS. I'll look it up for you later, because are you familiar with that paper?
I'm not familiar with that paper.
I think I
Okay,
glanced at it once.
it's a 2 years, 3 years old. It's
Can
a
you
uni-
summarize the results for us?
Well, they looked at various data structures and applied synthetic bit flips, and then watched the result and determined, how bad the corruption was. And like you pointed out, you could lose a bit of data. You will never get served corrupt data. And that's the big assurance. But if you are very unlucky, you could lose the entire pool. That's
I think that kind of coincides with what we were saying.
yeah.
All of those are possibilities.
But this was a sort of this paper was a formal analysis of. Oh, you have it?
I have it. It's the end to end.
Yeah.
Claim you can't lose user data.
That's clearly not.
Yeah.
That's a limitation of their testing for sure.
But yeah, the paper's called End-to-End Data Integrity for File Systems, a ZFS Case Study. So maybe I'll put that up on the meetup,
Yeah.
just so
Yeah.
everyone can have a read of it and then have a further discussion on the OpenZFS mailing list.
Yeah, and I think your question about like practical tools for recovery is certainly an apt one, and there's work to be done there.
Yep.
I know Drive Savers has done some work with ZFS. I've heard of people sending them pools and getting some data back.
There are only very few people who master the ZDB.
Yeah,
Yeah, no, but
yeah, I know.
and Igor also he led the way, but there are very few people who are able to manage to actually salvage information from a lost pool, and that's work that needed to be done.
Yeah, that'd be a great.
Frederick,
talk
you've got
at
a great
the
hackathon
OpenZFS
project for
Developer
tomorrow.
Summit,
Yeah, it would be.
Actually,
I already have my project.
yeah. But maybe
Too
we
many
can
projects.
get someone to give a talk about this at the OpenZFS Developer Summit in November.
Yeah, sounds
That'd
good.
be great.
So, any other questions? Anything else on any kind of OpenZFS topic? I think we'll. Sure. Okay.
It was great to have the ZFS reference, like who uses ZFS. Well, third biggest supercomputer, IBM Sequoia. That was great reference. The story's getting a little old. Do you have other amazing references about ZFS we can use in our marketing? Impressive ZFS references?
ZFS users.
I mean, Delphix doesn't really, but I know there are other people in this room that could potentially give some good quotes about terabytes, petabytes under management of ZFS. I don't know.
What's a petabyte these days?
Yeah, petabytes nothing, but exabytes, gigabytes,
Not
zettabytes.
Not just volume, but also just like prestigious reference.
Okay.
When
big
a client
names.
says, "Yeah, well, you're anti-corruption technology, never heard of it. Who uses it?"
Oh, yeah.
Well, only the third biggest supercomputer on Earth. That was kind of.
Yeah, I think part of the problem is that there's probably some really prestigious names that may not realize they're using ZFS.
Yeah. So I
Right.
mean, for example, like our customers are like 100 of the Fortune 500, 100 of the 500 biggest companies in America use our product. They're using ZFS. They're relying on it for the core of their IT organizations. They may not even know that they're running ZFS because it's just embedded in our product.
But here you have it. 100 of the Fortune 500, because they use Delphix and it's all and it's all ZFS.
And I'm sure you guys have similar quotes like that, right?
Yeah, it's probably easy to look at the companies, right, on the OpenZFS page. It's probably easy to look at the companies on the OpenZFS page and then go to their customer references. I know Nexenta has a lot of them that they publish.
We can't name names here just to do the talk because we don't know.
Yeah.
And
But I'm sure if
part of it is certainly sensitive info. But if you go just to the company pages,
yeah, all of us have all these companies have reference customers, right? So you go to Delphix.com, you're going to see all of our reference customers. I'm sure if you go to Nexenta.com, they're going to be like, Nexenta used by X, Y, and Z, and they're all going to be like household names. One of our reference customers is Facebook, right? Facebook uses ZFS in their IT organization. So,
I suppose if there's no more questions, I suppose we'll close out. We're going to go and enjoy some beers and some pizza. So thank you very much for coming. Thank you very much for your support. Thank you to everybody on the live stream for viewing. I know there was hundreds and thousands of people watching.
so nerve-wracking.
Yeah. But anyway, so thank you very much for your support. And let's go have a beer together, chat some more ZFS, and have a good time. And we'll wrap it up for today. So thank you very much. And
thank you for organizing this, Ryan.
Thank you. It's been great. And it's not just me; it's Yassine, Sebastian, Francois. So thank you to the Alicio team as well, and Nicole 42.
Thank you guys.
And and thank you guys for coming and supporting it. So, and